All right, guys, we are going back into the second section of our hair notes. So let me get this rolling. I believe we saw this slide in class. So overview of hair located everywhere except palms of our feet, palms of our hands, soles of our feet, and our lips. Functions in animals for warmth and defense, and more specifically in humans. Yes, we are animals, but a little more evolved. Hair is for protection and sensation. So structure of a pili. A pili is a one single hair. So what should we know about hair? It is made of keratinized cells. So remember keratinocytes from the epidermis. And remember that all of these accessory structures are derived from epidermal tissue. So in this picture, oh, I've lost my pointer. In the picture, you can see the epidermal layer at the very top of the diagram. It's kind of a purplish color, and then it plunges down and surrounds the actual hair follicle. And so the hair structure is keratinized cells, which should make sense because keratinocytes are the primary component of the epidermis. Now, there's two major regions of a pili. The shaft is what projects from the epidermis, and we saw this in our hair lab a couple of days yesterday. And the root is what is embedded in the dermis. We also briefly talked about in our hair lab background that really cells are dividing in the root region, a specific region of the root called the matrix that we'll see here in just a minute. And those cells are dividing and then pushing the hair up and out of the skin. And so hair grows just like epidermis grows from the base layer, and then those cells migrate away from or become more superficial as they migrate. There are melanocytes down there in the matrix region as well. And so your hair is the color that it is because same cells that are cranking out color for skin are cranking out color for hair. If we look at a piece of hair, which is called a pili, and we cut into it, a cross section, we would see that it's made of three primary layers. So the cuticle is the outermost layer, and the top photo is an electron microscope photo, which really shows you the surface of hair. And so you can kind of look at the actual hair and see that it almost looks like these little scales that overlap each other, kind of like roof shingles would overlap each other. That's the cuticle. And the cuticle is intentionally structured to prevent our hair from clumping up and matting up. The cuticle also offers some protection in the form of preventing water loss. In the picture below, the cuticle is everything that you see in the outermost, that kind of dark brown, thin layer covering the hair. If we move into the next layer, we find the cortex. And so the cortex is a very big, bulky layer, and it surrounds what is the innermost part of the hair, which is called the medulla. The important thing about the cortex is that this is where the pigment for hair color is stored. And then you have the very innermost middle of a hair pili, which is called the medulla. You have very large bubbly cells in here and some air spaces as well. If you looked under the microscope in your hair lab and you thought you saw a really thin kind of innermost dotted line almost inside of your cells, you were probably seeing some of the medulla. I want to talk about not just the pili, which is the hair, but the entire hair follicle, which is funny enough sometimes called the hair bag. So if we talk about a follicle, all of the things that we're getting ready to list are part of the overall follicle. The follicle really supports, nourishes, and provides sensation to the overall pili, which is a hair. You have this diagram in your notes. And so as we talk about some of these things, I would encourage you to circle the words that we talk about and or highlight them so that you know where they are located. So we have the bulb, and we talked a little bit about the bulb before our hair lab, using the background reading. The bulb is embedded in the root. And so in the very middle picture here, you can see this sort of bulbous bottom. The bulb will contain really blood flow and nerve supply that is helping to support the growth of new hair. So within this bulb region, we have something called the matrix. The matrix is a very thin layer. In this diagram, if you look closely, the matrix is really just one cell layer thick. But here is sort of equivalent to the base layer of the epidermis. This is where all mitosis is going on. And so this is where new cells will come from as the actual pili grows. You will find little tiny dark cells embedded in this matrix in the diagram as well. Those are the melanocytes that are producing melanin, depositing them into the hair cells, the keratinocytes, as they are born and sort of migrate away. So the hair matrix, lots and lots of hair growth coming from here. The hair papilla is really this cavern that exists, this sort of cave-like structure that exists underneath the matrix. And jammed up in this cavern are blood vessels. So the important thing here is that the hair papilla it's a pocket of space that contains capillaries, and those capillaries are providing nutrients to the matrix that's sitting right above it, which is producing new cells constantly. And those new cells need to be nourished. They need nutrients to live. And then the other important structure here is the erector pili muscle. And you have to kind of look at the top diagram for that, the one that's a little more like a square or a column. Is a little muscle that attaches itself to the bulb, and that attachment runs back up to the top of the epidermis. This is a smooth muscle, and it exists for a reason. It is, when contracted, it will move your hairs. And so this is part of the reason that when we get cold and we start to shiver, our hairs stand up. Those erector pili muscles, all of our muscles, when we get cold and we start to shiver, all of those little skeletal muscles and even some smooth muscles are going to contract in an attempt to generate heat. And then what we visibly see are these goosebumps that appear when the muscles under the skin are contracted and the hair is pulled up. These are also what kind of raises the hairs on the back of your neck when you get frightened or scared. So the contraction of the muscle will raise the hair, and when the muscle relaxes, the hair lays back down on your arm or your leg or your body. There are a couple of different categories of hair. I see that picture blocked some of our words, but the two main categories of hair are vellus and terminal hair. Now, another name for vellus might be lanugo, if you see that in text or in like a question stem. So vellus hairs are very thin and pale and fine. They're sometimes likened to sort of peach fuzz, and they are this way because they don't have a cortex region, which means they really don't carry a pigment, because the cortex region carries the pigment. We find a lot of vellus or lanugo hairs in women and kids, especially at birth. So if you've ever seen a baby that is really a newborn baby, they might be covered in these little tiny thin velvety-like hairs. That is a vellus or a lanugo hair. Now, they'll shed a lot of that within the first week or so of life, but we're all born with these very, very fine hairs. They continue to remain primarily, I think of like the hair that exists on your face, ladies, that hair that's very fine and very soft, those are vellus hairs. Terminal hairs are very different. They're coarse, they're long, they're dark, and really they grow in the presence of androgen. So think of the hair development that occurs at puberty. The hairs that grow darker and longer and thicker at puberty, those are terminal hairs. And so if you maybe sampled a leg hair or an arm hair, you might have noticed in the hair lab that those are pretty dark and pretty coarse because of the hair type that they are. Let's talk about hair growth for just a second. Hair growth rate is pretty constant. So hair grows, regardless of where it is on your body, grows at about 2 millimeters per week on average. But hair grows in cycles, and that's what this picture is showing us. So not all hairs will rotate through this cycle at the same time. And so I'm going to take the words away for just a second so we can look at the picture. So you can see, I'm not going to ask you to know the fancy names, the words that are in parentheses, anagen, catagen, telogen, but you should be aware that there's a growth phase for a hair. That's the anagen. And then after the hair grows and is actively growing, again, approximately 2 millimeters per week, it will start to shrivel up. It will go into a period of rest, and then it will fall out. And from that point, you regrow the hair and you're back in the anagen phase. And so even though hair growth rate is constant, hairs go through this cycle at different paces. And so not all hairs are in the same rotation in the cycle at the same time, which is why you can lose hairs from your head and not be entirely bald. And we'll talk about balding in just a second. But in general, you're losing quite a bit of hair each day, but it doesn't make an overall difference in your appearance necessarily, because you have other hairs that are in the actively growing phase. If you've heard of laser hair removal, you have to go multiple times for it to really take. And really, the reason for that is because the laser hair treatment is only targeting the cells that are in the growth phase. And so, or the hairs that are in the growth phase. And so, because not all hairs are in the same phase at the same time, you might have to go back repeatedly to get the ones that were resting and falling out when they hit their next growth phase, until you have gotten all of them within their growth phase, and then you've truly removed all of the hair. So here's an example of what I mean. Scalp hair, you know that you can grow your scalp hair really, really long. They exist rotating through this cycle about every 4 years. But an eyebrow or an eyelash, which is much, much shorter, goes through this entire cycle about every 3 months. And so even though the growth rate is constant, the turnover is much faster for eyebrows and eyelashes, which is why they stay shorter and they're not these really, really, really long hairs on our body. A couple of clinical conditions, medical conditions, maybe if that is helpful to you. The first one is called alopecia. And so alopecia is when you're losing hair faster than you are actually replacing it or growing it. So your hair is resting and being released faster than it is actually growing. And that could be for a lot of different reasons. Alopecia could be connected back even to our immune system. And so for some reason, you are not able to replace your hairs as quickly as you are losing them. And so you form these sort of patches. Now, what I would say about the patches here is that this is different than being bald or going bald per se. And the reason that I can tell that is we see some asymmetrical, sort of patchy hair loss. That is different from what we're getting ready to talk about next. So alopecia. Next is male pattern baldness. So male pattern baldness is totally different. Oh my goodness, I'm all over the place. Sorry about that. Male pattern baldness is totally different. First, there's a genetic component. So if you want to look at the opportunity or the chances of you becoming bald, you actually need to look at your mom's dad. So that would be your grandpa on your mom's side. So you're inheriting this from your mom's paternal DNA, the DNA contribution that your grandpa gave to make your mother. And then she possibly passes it down to you. Now, the interesting thing is that you could inherit the gene, but you have to then turn the gene on. And once you turn the gene on, you're going to start making more testosterone receptors on your hair, and in the presence of testosterone, the hair will actually fall out. So there's a reason that oftentimes, even though this is coming through mom's lineage from your mother's DNA, the reason that males typically express it more is because you really have to trigger this gene with testosterone, and males have high amounts of testosterone. So if you look in your notes, there's a reason that it's called male pattern baldness. It really does form a pattern. And so you can see the common pattern formations there. One looks kind of like a widow's peak. The other eventually produces what I would call like the halo around. So the top is bald, and then the other two are sort of progressions of losing that widow's peak even further back. So male pattern baldness forms in a pattern, which is very different from what you're seeing there with alopecia. That is not a patterned baldness. It's quite patchy and asymmetrical. Now, you can also lose hair because of hormones. And so, one of the biggest examples of this during pregnancy, your body really, there's our pattern baldness slide. During pregnancy, mother's body really goes into conservation mode. And so, her body will save everything, which means hair even as well. So the hair will remain in the active growing state, and it won't shed and be released. But then after the baby is born and hormones sort of shift, all of that hair that was saved will start to purge. And so after childbirth, a couple months even after you've had a baby, women will lose hair in just clumps. And it's because of a hormone change, but also because their body was conserving anything and everything during pregnancy to try to grow that baby, including hair. And so we've got a lot of hair over 9 months to then shed. Two kind of interesting conditions that I'll bring up here regarding hair. Trichotillomania. Now, that's a big word. I wrote it for you on your notes. Trichotillomania is kind of a manifestation of OCD. It's a compulsive behavior, and the compulsion is to pull your hair. A lot of times people will pull their hair from their face, from eyebrows, eyelashes, their scalp. And so you will see, kind of like this image is showing, you'll see sort of patches of hair growth, dark hair growth, light hair growth, because again, as a compulsion, you can't really control it. You're pulling your hair. Now, there's lots of reasons why this might develop, and we're not necessarily going the world of psychology right now, but trichotillomania is hair pulling. Trichotillomania can also extend into trichophagia. So trichophagia is when you eat the hair that you have pulled out. And these are two really common conditions to express together. Most of the time, people are eating kind of the root, the bulb, and a little bit of the shaft if they're choosing to eat. Now, the issue is that your body has a hard time breaking down hair in the digestive system. And so you could potentially form essentially a really big hairball that's called a trichobezoar, and that could block your intestines. And if you block your intestines, you are in a bad position, mostly because you could start to restrict blood flow to your intestines and kill off some of that tissue, which is not good. So, interesting kind of clinical condition, trichotillomania, the compulsion to pull. Some people with mania also experience aphasia, and they will eat their hair, which can lead to a bezoar. Last section of notes, nails. Nails are pretty quick here. There's not a ton to talk about. So in the overview section, your nails are really thick, dead, keratinized cells. And so they're extensions, again, of the epidermis. So that keratinized cell component shouldn't be too unfamiliar to you because the epidermis is loaded with keratinocytes. There are 3 parts to your nail. There is the root, the body, and the free edge. And so you can find that on the diagram, the root, the body, and the free edge. Hold on, guys. I'm getting a call. Oh, well, never mind. By the time it loads that, we're just going to keep going. They'll call back. Okay, where were we? Here we go. So root, the body, the free edge, and you can find those on your diagram. You've labeled them on your LT2 diagrams as well. Underneath the body, there is something called the nail bed. The nail bed, keep in mind the nail bed in this diagram, it's kind of a reddish color. It's going to provide blood supply to the tissue below. And so in a minute, when we talk about how your nail has different colors to it, oh my goodness. Hold on. Back me in. Hi, hold on one second. Okay, and we're back. So, sorry. Okay. So, all right. If we look at some additional, so we know that there's a root, there's a body, and there's a free edge. The root is embedded back in your skin. The body is what you see, and ladies or fellas, what you would paint if you put nail polish on. The free edge is anything that hangs over, that is sort of like your nail tip. So within those, let's talk matrix. The matrix is in the root area, and so it's embedded back in your skin. This is just like the matrix of the hair. This is the highly mitotic region where new cells are being divided or are dividing, and where your nail is growing from. And the matrix traditionally creates a very thin layer of cells that grows out over the body and forms this thing called the nail plate, which you don't have to know, that's fine. But it grows out over into the body, and it's so thin that if you kind of look at your nail, if you don't have any fingernail polish on it, if you kind of look at your nail right now, your nail looks kind of pinkish. And if you actually push on your nail, it will blanch, which means the color will go away from it. When you release your pinch, it will be kind of white and then it will refill. That is because your nail is really thin on the top and you're able to see all of the capillaries in the nail bed below. Now, there is a region of your nail that is kind of white. And so this is called the lunula, which literally translates as the little moon. And this appears to be white because just at this part, right where we enter into the skin, it's a little bit thicker. And so you're not able to see the blood flow underneath in the nail bed. And so it appears kind of white in this extra thick area. If you're looking for yours, it's easier to find in your thumb. And then as you kind of go across your hand to your pinky, it probably gets smaller and smaller and smaller. So the lunula, or the little crescent moon that is kind of white on your finger, is white in that particular spot because the cell layers are thicker and you can't see the blood flow in the nail bed below. Last thing we'll talk about is the cuticle. So the cuticle is a fancy name for the cuticle, epunctium. The cuticle is an extension of the epidermis onto the surface of your nail. So it's all dead epidermal cells, keratinized dead cells, which is why if you've ever trimmed your cuticles, it really doesn't hurt. And it's really there as a protective, waterproofing mechanism. And so you can, if you've ever had a manicure, they trim your cuticles. You have cuticles on your toenails as well. And it's okay to trim your cuticle. It is not okay to trim deeper back. Then you're talking about actually killing cells or breaking into cells that are living tissue, which hurts, number one, and also can promote infection, bleeding and infection. But the cuticle itself is dead. It's just like when we go get a haircut, it doesn't hurt to cut our hair. It doesn't hurt to remove some of your cuticles. This is just a fun fact. This is the Guinness Book of World Records for the longest, the guy that has the longest nails. He stopped cutting his nails in 1952, and now they're 4.25 feet long. And you'll notice that as nails grow, they actually don't grow straight forever. They will start to, because this is just keratinized, protein, they will start to coil. So not exactly sure why he chose to grow his nails that long, but kind of interesting. There's only one clinical condition that we're going to talk about with nails, and it's a clinical condition related to toenails. So I'll give you a second to read this little cartoon, and we'll see if you can see what we're talking about. Ingrown toenails. So ingrown toenails, you can also have ingrown fingernails, but you'll see why toenails are more common than fingernails to be ingrown. So what are these? This is when your nail grows into your actual skin instead of growing out over your skin like it's supposed to. Why might this happen? There could be a genetic predisposition for sort of the growth of the cells and the protein that the keratin is the protein that is keratin being produced. And so genetically, you might have curved or thick nails. More than likely, it's because of either injury or restriction. And so pointed or tight fitting shoes. And that gives kind of rise to why we see ingrown toenails more than we see ingrown fingernails, because we don't restrict our hands much. We don't have our hands in tight, controlled environments like we do our feet all the time in shoes. How do we treat it? Most of the time, ingrown toenails that you are seeking treatment for, they're going to have to remove part of that nail, which you can see in this particular photo. That's a pretty severely ingrown toenail. And so you're going to have to do a little bit of a surgical procedure to be able to kind of pull out the nail that has grown inside. And then they will pack it with sort of cotton or a fabric underneath to help it grow straight as the new nail grows back out. How do we prevent this? Doctors would say, home remedies for ingrown toenails. Make sure that you're clipping and trimming your toenails. That's what attentive grooming means. Round the edges of your toenails so that they don't kind of square off and grow down into your flesh. But then also make sure if you struggle with ingrown toenails that you reduce any pressure on your toes, that you get your feet out of shoes as quickly as you can. A lot of athletes can have ingrown toenails just by the nature of cleats and particular shoes that you need. So really try to remove the obstacles and see if that is helpful. That is the last slide. That wraps up the last section here of your LT2 notes.